Hi and welcome. I hope everyone is okay. And for everyone, have a nice weekdays. Uh, as you remember, the last lesson we stayed in the position distribution topic, but now today we will learn in the different part of the position distribution. We will learn to use the normal distribution as an approximation to the Poisson distribution. But before I start to teach the lesson, I show you something about Google Classroom. When you enter your Google Classroom account, you can see easily, uh, for example, a static probability and statics your account. And when you click the classwork, if you notice that the top of the page, you can see stream, classwork, people, grades, and when you click the classwork, you can see all homework. In this folder, your you have all in your you have all homework in this folder, and I want you to follow these folder uh, for doing your homework. For example, the position distribution exercise 2A, and you can see easily instructions and due date October 14, and maybe you can see the other homework, for example the position distribution exercise 2B. So when you click the instructions, you can see these instructions, and you can see the exercise 2B page number 2C, and you can see easily due date. So I want you to notice that only follow your Google Classroom account, all homework section, all homework folder. Okay. uh, I hope it's clearly for your doing for doing homework. And then I want to start our lesson. Okay. Now, using the normal distribution as an approximation to the Poisson distribution in this topic, please remember that to compute is easy, that the probability of some values in the Poisson distribution. For example, to compute this probability, very easy. For example, we have a formula about Poisson distribution. They want us the probability of 5, exactly 5. So our formula is the probability exactly R means e2 minus lambda multiply lambda to R over R factorial. So 4 is our mean average or lambda value, and 5 is we want to probability value. So our value is 5, and the probability of 5 in Poisson distribution, lambda 2 R over R factorial multiply e2 minus lambda minus 4. But sometimes to compute either is so hard the probability of some values in the Poisson distribution. For example, if we want to probability greater and equal than 10, less than 30, we should compute the probability of 10 plus the probability of 11 plus the probability of 12 plus and finally the probability of 30. But this process is very hard because we will compute about 21 probability value, and then we will sum all them. So when we come across to this situation, we should improve a different way. So we will improve the normal distribution approximation to the Poisson distribution, and we use the normal distribution approximation to the Poisson distribution with negligible mistake defect. We won't find exactly value, exactly result, but we will find negligible mistake defect. So why do we use the normal distribution? Because when the number of trials n is so large, sufficiently all distributions tend to the normal distribution. And then please notice that these graphs about Poisson distribution, and please remember that Poisson distribution is discrete distribution. Poisson distribution is discrete distribution. So these rectangles about Poisson distribution. But if we draw the middle of the middle top of the rectangle curve, we can create the normal curve. And please notice that when your lambda values increase, your curve tend on the normal distribution. When your lambda value is 10, your curve like this. When your lambda value is 15, your curve like this. And when your lambda value is 20, your curve like this. And when the lambda value is 20, your curve tend to normal distribution curve, very symmetrical curve. Please notice that in this section. Notice that as the value of lambda increases, the Poisson graph improves as a fit to the normal curve. The shape of the Poisson distribution graph is always skewed. Don't remember our Poisson distribution discrete distribution, and this Poisson distribution graph is always skewed. But for larger values of lambda, the Poisson distribution graph resembles the shape of a normal distribution. And please remember that in the Poisson distribution, our lambda means nu, and in the Poisson distribution, nu and variance the same. So in the if you work on the Poisson distribution, your average, your mean, and your variance the same. The other hand, in on the other hand, accuse each other. So if you use the normal distribution approximation to the Poisson distribution, your new value becomes lambda, your variance becomes lambda. So if you want to standard deviate, so sigma, you know, sigma is equals to square root of variance, so square root of lambda. And the normal distribution, the first value is nu, the other way lambda, and the second value is variance, and the variance means, you know, sigma square, or in the Poisson distribution, sigma square and nu the same value, so you can use in the normal distribution lambda and instead of variance you can use lambda again. A Poisson distribution is a discrete probability distribution, and so to use the normal distribution as an approximation to the Poisson distribution, a continuity correction has to be applied, just as one has to apply it when using the normal distribution as an approximation to the binomial distribution. Please remember that a normal distribution, a continuous distribution, but Poisson distribution is discrete distribution. These rectangles about Poisson distribution, this curve about normal distribution. So if you want to use normal distribution to approximation to the Poisson distribution, you should please remember that you should continuity correction, and you should convert to x value, convert to z value, and please remember that the previously lesson we reviewed about last year's topics, and we reviewed about this continuity correction. We used to continuity correction when we want to discrete probability convert to continuous probability. For example, binomial distribution is a discrete probability, and if we want to use normal distribution instead of binomial distribution, we should use and make continuity correction. And for example, Poisson distribution is a discrete probability, but normal distribution is a continuous probability. And when you want to normal distribution instead of Poisson distribution, you should make continuity correction. X value convert to z value. So when you want to x convert to z value, you should this section z equals to x minus nu over standard deviation. But please remember that in Poisson distribution, nu means lambda, and standard deviation means square root of lambda. So when you make the continuity correction in Poisson distribution, you should this formula. You should do this formula: x minus lambda and over square root of lambda. Okay, and this very important. It's very important for us. The accuracy of this approximation improves as lambda increases. Remember that our graphs, for example, lambda when lambda value is 10, your curve is skewed. When lambda value is 15, your curve is a little bit skewed, but lambda equals to 20, your curve very similarly normal distribution or symmetrical curve. And when your lambda value increases, your Poisson distribution tend to normal distribution. Okay, now we have some example about this situation. Assume that Manuela posts pictures on her social media page at random points in time. She posts on average 24 pictures each week. Let the random variable x be the number of pictures posted each week. Then x Poisson distribution 24. 24 means lambda. So our lambda is 24. And if you want to find the probability of any n value, you can use the probability Poisson distribution formula, and it means 24 to n over n factorial multiply e2 minus lambda minus 24. And if you want to use Poisson formula, if you want to use the normal approximation, Poisson formula and the normal approximation between hasn't more differences. For example, if you want to find the probability of 30, if you use the Poisson distribution formula, you can find 0.0363. But if you want to normal approximation for solve this Poisson regarding to this Poisson distribution question, you can find the result is 0.0385, and this value between this value has a bit differences. For example, I want to remember Poisson distribution convert to normal distribution, and I want to remember you to correct continuity correction. And please remember that if you want to compute the probability of 30, you can use Poisson distribution. But if your lambda also 24 greater than 20, your Poisson distribution tend to normal distribution, and because of your lambda value is 24, and because of greater than 20, you can use the approximate normal distribution approximation to the Poisson distribution. But please remember that Poisson distribution is a discrete distribution, and if you want to the probability of 30, exactly 30, please notice the graph. You can find these section, but the normal distribution shows us area of under the curve. But if you want to find only one value distribution, only one value probability, it should be 0, because 1 point, also 30 points under the area of the under the curve should be 0. So we need to make continuity correction, and you want to find the probability of x exactly 30, and you should make continuous data. The middle of the rectangle, the middle point of the rectangle, this point, and I want to some big way, and you should this point, and between this point also this point means 29.5, this point means 30.5, and if you want to the probability of 30 by using normal distribution, you should compute area of the under the area of under the curve, and this area between 29.5 and 30.5. And if you use the normal distribution, the probability of x, the probability of 30 instead of the normal distribution, the probability of x greater and equal than 29.5, less and equal than 30.5. But you have make one more something. This is continuity correction. So when you want to continuity correction, you should use this formula: z x minus nu over standard deviation. But in the Poisson distribution, this formula means x minus lambda over square root of lambda. So the probability of our x value, the first one 29.5, the second one 30.5, so 29.5 minus lambda 24, please remember that, and over the square root of 24. Greater and equals than also z, and 30.5 minus lambda over the square root of 24. And when we return the this table, we can see the same process. 20 but this is it has a mistake, because 30.5, and this it should be 30.5. 29.5, it should be 29.5, and 29.5 minus 24 over the square root of 20 lambda. 30.5 minus 24 over the square root of 24. And if you notice that this section, this part, phi, it means 1.327, 1.123, but it changed. It should change. So the probability of z less and equal than 1.327, greater and equal than 1.123. And we should remember one more thing, and we should remember to use the normal distribution curve. Please remember that the normal distribution curve, very symmetrical curve, and the middle of this curve means 0, and we want to greater and equal than 1.123, this section, 1.123, this section, the other less and equal than 1.327, 1.327, and we want to compute that the right of this point and the left of this point. So we want to compute the area of the normal curve. And please remember that we should use Z table, and when we look at the Z table, and when we look at the phi 1.123, the Z table shows us the big area, so we can find this area. And if we want to find this area, the big area, this area, for example, we should look at the Z table. 1.123, 1.123, 1.1, this 1.0101112. Okay, Also, we should look at the 3. So this is 6. This value is 1.12. This 0.006 for the third decimals value. The third decimals value. So if you want to compute 1.12 also 3, you should look at the 3 and 0.006 should add to this value. It means, that if you want to compute 1.12 means in the about Z table 0.8686, but 0.003 you should look at this section, and it means you should add to 0.0006 and 12, 9, 6, 8, 0. So it means 1.123 phi according to Z table means 0.8692. If you look at the table, 1.123 means 0.8692. 0.8692. If you want to phi 1.327 phi 1.327, before you should find 1.34, 1.3 and 1.32 this. Okay, this is 1.3. 1.32 means 0.9066, 0.9066, but you have one more digit, 7, and you should find on this part 7, and 7 is 11, goes to 11, and 7 goes to 11. If you want to 0.007, you should add 0.0011, and it means 77090, 0.9077. If you look at the table, phi 1.327, 1.327 means 0.9077, 0.9077. Okay, and this value means on the normal curve accused to big area, and 1.327 means the big area means 0.9077, 0.077. It means 0.9077. And if you want to between these values araya, so you should make subtraction. So you should 0.9077 subtract or minus 0.8692. Please remember that we could find this value, this area, and if you figure out this section 5 and 8 and 3 0, this 0.0385, 0.0385. If you look at this table, 0.0385. If you figure out by using normal distribution, your result 0.0385. But if you want to figure out by using Poisson distribution, your result is 0.0363. It means a very nearly values. So if your lambda greater than 20, you can use normal distribution, normal curve, but please don't forget continuity correction. Don't forget also change the interval, and you can compute easily the Poisson distribution instead of the normal distribution. And we prefer the normal distribution instead of the Poisson distribution, because the normal distribution as using the normal distribution very easy instead of the according to Poisson distribution. Okay, now the next lesson we will go on and we will review changing to interval. For example, the probability of between 29 and 31, and we will review the change the interval between 24 and 26, and the other section we will review. And the next lesson we have two example about the normal distribution, using the normal distribution instead of the Poisson distribution. For now, our lesson is finished. I hope the lesson is the lesson became useful for you about understanding to use normal distribution instead of Poisson distribution. But the next lesson we will go on what we stay there. For now, have a nice day and have a nice lesson.